Okay, I appreciate you guys taking the time to watch these videos as they will help us a lot when we come back to class on Tuesday of next week so that I'm not going to go through these problems in class. I will have a couple other ones, but you're going to be in so much better shape if you take the time to watch these videos before coming to class so that you're kind of a little bit more up to speed. You'll learn a little bit more about Unit 2 as you practice those in Alex, but it's different on paper and pencil, so the process is a little different. So when we did this last example up here, they gave us a formula or a function right here, and we identified that the parent function was square root of x, right? From time to time, they're gonna actually just give you a function and tell you this is f of x. Now I want you to know this isn't any of the parent functions I have. This isn't square root of x, right? This isn't x cubed or anything like that. This is just a function that was created for us. So it says given the graph of the following function. Well, we want key points, right? So like what are those key points? Well, we can see that they're on the graph, right? Like this is the key point, -6, 0. This is going to be one of our key points, which is -3, 3. So we have all of these points, 1, 2, 3, 4, 5 of them that we're going to be using as our key points, okay? So we get to actually kind of skip the first couple steps where we say, what are the key points for the x, or what's the parent function and what are the key points? We get to move right to the point where it says list the transformations that have taken place in a correct order that so that we take the graph of f and we get to this new function p of x, which is negative f of parentheses 3x plus 1. So this one looks a little different, right? Like when we had this one, we said, okay, underneath the square root was inside. Well, with the inside of the function here for f, we're going to look inside of the parentheses in that f of x notation. And I can see right there that there is a 3 inside, right? Now I want you to go look at your notes. I'm going to give you a couple seconds here and see if you can identify what that transformation would be. So remember, if it's multiplication, it's going to either be a stretch or a compression. Since it's on the inside, you always know that we should start with the term horizontal. Horizontal. So this is a horizontal. Is it a stretch or a compression? This is where things are a little weird on the inside of the function. So things happen a little differently. So if it's outside, we multiply the y values by 3. But since it's on the inside, what we're going to do is it's actually a horizontal compression by a factor of 1/3. And I know you're like, Nick, what? How did you get the number 1/3? I see a 3 there. Well, what happens is rather than so when we did this one up here, we multiplied our y values by 1/2 because there was a 1/2 outside. Since there's a 3 on the inside, you don't multiply the x values by 3 over 1. You multiply by the reciprocal, meaning flip this fraction over. What do you get? 1/3. So what we're going to actually end up doing, and I'm just going to go ahead and answer this question right now. What operations do we apply to the x values? That's the only thing happening on the inside. So you're going to take the x values and you're going to multiply them by 1/3. I'm going to give you an example of this again in class to further clarify. I will tell you that I think horizontal stretches and compressions are some of the more difficult ones for students to wrap their heads around. So we'll continue to revisit this topic again and again as we go throughout the semester. But for now, let's just flip the 3 over. 3 over 1 flipped over is 1/3. So we multiply the x's by 1/3. That's why it's a horizontal compression. Okay. Now let's move to the outside, see what's happening there. I see a negative outside. What do we remember with negatives? When we had the negative on the inside in this last one, it was a reflection. Well, same thing on the outside. It's just not a horizontal reflection. This is a vertical reflection over so since it's vertically reflecting, it's flipping this way. So it's actually flipping over the x axis. Okay, one last transformation going on here. There's this +1. That plus 1 is on the outside, so this is a vertical shift up 1. Now the stuff that is vertical is going to be affecting the y values, so what we're going to take is our y. We're going to reflect it, so we're going to make it negative or multiply it by -1. That's the same thing. And then we're going to shift it up 1, so that's going to give us a plus 1 right there, okay? So we reflected this vertically. We're going to shift it up 1. All right, let's get those key points. I'm going to zoom out, copy them down, and then I will zoom back in here for the next step. So my key points are -6, 0, -3, 3, 0, 0, 1, 1, and 3, -1. Go ahead and double check -6, 0, -3, 3, 0, 0, 1, 1, and 3, -1. All right, and I will label those as our key points. Now I'm going to zoom back in real quick so we have a better sense. So what we're going to do is we're going to multiply our y value or our x values by 1/3, and then we're going to take our y's and we're going to make them negative, and then we're going to add 1. Okay. So let's get these points. 1/3 of -6, well, 6 divided by -3, it's going to give us -2. And then -0 plus 1 is 1. Again, I'm just taking the x and we're doing 1/3 times -6 for our x value. We're kind of applying that formula. And then -0 plus 1 gives us that value, okay? Now, 1/3 of -3 is -1. Oops. And then -3 plus 1 is -2. 1/3 times 0 is still 0. And then -0 plus 1 is 1. 1/3 times 1 is 1/3. -1 plus 1 is 0. 1/3 of 3 is again 1. -1 is +1, plus 1 is 2. So again, I just took each of these x and y values and plugged them in for x and y here to get these different points. There's a lot of these. I'm not going to label all these, so we can just go ahead and think, okay, we're going to graph these by ones. So -2, 1 is right here. -1, -2 is right here. 0, 1 is here. 1/3, 0, I'm going to have to kind of estimate that, but I'm going to say that's right here. And then 1, 2 is right here. So we can see what this is creating. It's got kind of like a W shape going on here. And we can see that it's been flipped over, right? So this has this shape, and if we flip it over, that's how we get that W shape. We can see that it has been horizontally compressed. So we like took it and kind of shrunk it horizontally, and we flipped it, and we also see that that is shifted up 1 as well. So that's how we get that graph.